to the Engineering Update. I'm technical editor Jason Lundberg, and in this week's episode, the most secure drone in the world, studying weightlessness for long-term space voyages, and kicking a soccer ball using mind control. It wouldn't be an exaggeration to say that unmanned aerial systems have fundamentally transformed warfare. But one of their greatest strengths, remote control, belies their most acute weakness, a vulnerability to hackers and malicious software that could bring down these flying instruments of destruction with minimal cost and effort. And in one of our greatest foreign policy embarrassments of the last decade, militants in Iraq hacked US Predator drones in 2009 using $26 off-the-shelf software. In 2011, Iran took it one step further, downing an RQ-170 Sentinel by feeding it false GPS data and then displaying the UAV for the whole world to see. To address these vulnerabilities, DARPA has been developing a program called High Assurance Cyber Military Systems, which uses software to thwart all manner of cyber attacks. The project originated at the University of California, San Diego and the University of Washington, and according to the program manager for DARPA, the software is allegedly mathematically invulnerable to large classes of attack. And while we hesitate to throw around words like invulnerable and bold claims like hack-proof, that sounds like a challenge, DARPA's prototype drone performed admirably during mock attacks and tests lasting more than 18 months, where hackers tried and failed to hack into the quadcopter. This led DARPA to declare its prototype the most secure UAS on the planet, undoubtedly making it a giant target for hackers worldwide. The Pentagon hopes to apply the software to larger UAV platforms.
Given the complicated political, social, and financial conversations that often surround space exploration, it's easy to forget we aren't the only living things hanging out up there. And by living things, I don't mean some sort of alien life form, but rather something a little bit smaller. Rodents, including rats and mice, have been an integral part of space research since the first great mouse adventure on the V-2 rocket in 1950. Though they are often overshadowed by the flashy accomplishments of chimps and monkeys, rodent research has contributed to important takeaways about space medicine via 27 batches sent between 1983 and 2011. These overlooked heroes are about to get a new humble abode with the launch of a new habitat aboard the SpaceX Dragon cargo ship. This particular batch of rats will be used to study the effects of weightlessness on long-term voyages in preparation for sending humans to places like Mars. The new enclosures, which include a transport module that fits in racks on the pressurized portion of the cargo ship, will be placed on the International Space Station for a 6-month duration, or about a third to a half of the rat's life. The modules are designed to be easily transferable from ship to station, and the animals can be accessed by the astronauts on board. Each one will hold 10 mice or 6 rats and offers food, water, lighting, and air, along with floor and wall rods that allow the rodents to safely move about their enclosure. On the tech side, the enclosures include data links and visual and infrared system that will allow for better study of the rodent's reaction to long-term space exposure. Interestingly, rats serve as a decent indicator of human response, as their organs, diet, immune system, and genomes are similar to their human counterparts. Their short lifespan offers an accelerated view of how a 2-year voyage could affect humans. Well, bon voyage, guys!
While soccer star Landon Donavon's baffling omission from the US national team has dominated the early buzz surrounding the World Cup, an historic event of a different sort should take place in the host country of Brazil. Thanks to the Walk Again Project, a non-profit international collaboration between Duke University, the Technical University of Munich, and the International Institute for Neuroscience of Natal, among other centers of higher learning, a paralyzed Brazilian teen will make a ceremonial opening kick using a mind-controlled exoskeleton. Previous tests where microwires were implanted into the brains of rats and monkeys, enabling numerous tasks via mind control, confirmed the feasibility of such a device. According to Duke's Walk Again page, the flexible electrical prongs can detect minute electrical signals, or action potentials, generated by hundreds of individual neurons distributed throughout the animal's frontal and parietal cortices. This has been translated into a motorized exoskeleton that, if all goes well, will enable a paralyzed teen to stand up, rear back, and kick a soccer ball. And according to the Brazilian neuroscientists leading the Walk Again project, their efforts support a greater goal: the complete elimination and obsolescence of wheelchairs. That's all for this edition of the Engineering Update. Be sure to check us out on Twitter and Facebook, and check out past episodes on ECNmag.com. For the ECN channel, I'm Jason Lundberg, and thanks for watching.